it still takes a lot of time to build the infrastructure. And that's really the main problem because we don't have that time. So what gives me hope is that with ENG, we overcome all these limitations.
Hi everyone, my name is Carrie King and I'm a freelance journalist. Today I'm joined by Jens Schmidt, who is CTO of Tree Energy Solutions, otherwise known as TESS. Jens, could you please introduce yourself?
Yes, my name is Jens Schmidt. I'm the Chief Technology Officer in TESS, so in charge of the overall technology strategy, selecting the right suppliers and the right technology blocks to set up our TESS business model, which is all around ENG. So we're going to learn a bit about that in the next few minutes.
Thanks so much. And can you now please explain your key product, ENG, or electric natural gas?
ENG is electric natural gas, which is a synthetic molecule, a green molecule that is produced from renewable electricity, producing green hydrogen, and then combining green hydrogen with climate neutral CO2 to form methane, synthetic methane, which is the main component of natural gas. So it's similar to natural gas, but is produced entirely from renewable energy.
Thank you. And what makes ENG different to regular methane?
Yes, so the difference between ENG, electric natural gas, and standard methane is that, first of all, it's produced from renewable sources. So it's entirely non-fossil. It's coming from green electrons, from renewable electricity like wind and solar, which is then converted into green hydrogen by splitting water in electrolyzers, and then combined with CO2 to form methane. So the final product is almost identical to natural gas. Methane is 85, 90% of natural gas. So we have a molecule that is identical and can be used the same way, but is not taking out of the ground with all the emissions that go along with it, but is entirely produced based on renewables. So while the end product is the same, the way to produce it is entirely sustainable and climate neutral.
So, can you explain to me maybe why did TESS choose to develop ENG rather than working on a completely carbon-free alternative?
Yeah, so we definitely don't want to have the world stripped of all carbon. The human body is 98% carbon, hydrogen, and oxygen. So we definitely need carbon, not only for biological reasons, but also in the industry. If we look into the ways to transport energy, we need molecules. And the hydrocarbon molecule is the backbone of today's economy and industry. And therefore, while there's ways to transport hydrogen and other derivatives, the synthetic methane is the best way to do it because it's a drop-in solution to use existing infrastructure. We know how to handle the molecules and customers know how to use it in their process. So it's the best fit to have a fast and reliable decarbonization.
So, when you look at emissions in the test cycle, how do they differ from, say, natural gas?
Yeah, one of the main reasons we choose electric natural gas or ENG is that the emission profile is significantly lower. So if we just build a normal process with available state-of-the-art technology, we already have over 80% footprint reduction certified by external life cycle analysis. If we then add additional improvement steps along the value chain, which we're working on diligently, we can basically bring the whole footprint to zero. So the emissions that we have in the ENG cycle are much lower and can be much better controlled.
Okay, and how does TESS track and mitigate emissions?
Yeah, first of all, along the entire value chain from renewable electricity sourcing through electrolyzer, hydrogen production, and then methanation, CO2 transport, compression and liquefaction, and transport of the ENG, we look into each and every step because for us, two things are important. One is to drive the emissions down to zero because we want a true climate neutral zero emission solution. And of course, there's also an economic driver because ENG is our main product. So that's the only thing we focus on and that we sell. So every little emission, every little loss along the chain is an economic loss for us as well. So those two things combined, TESS being a green energy company, caring about offering a climate neutral solution, and reducing the losses along the value chain, make it essential that we track and optimize these. And of course, we're going to follow each and every step, doing the mass balance, how much goes in, how much goes out. And then we're going to use state-of-the-art monitoring devices to make sure that we detect and mitigate leaks and emissions along the chain.
We've mentioned a little bit already about the TESS cycle, what you call the green cycle. Could you explain, please, what the green cycle actually is?
Yeah, the test green cycle is basically describing the overall ecosystem that test sets up. So as described, we're going to start with renewable electricity coming from solar, wind, hydropower, anything that's climate neutral. And then we're going to turn that into green hydrogen. We're going to combine the hydrogen with climate neutral CO2 to make it transportable as ENG. So that's the upper part where we turn the sun into molecules, we make it transportable. Once we bring these molecules to the places where the industry is, where the energy demand is, and where there's no capacity to produce enough renewable electricity locally, that's where we import our green energy carrier. We can then offer three different solutions. We can supply hydrogen by converting the ENG, the electric natural gas, back into hydrogen and CO2, or we can provide green power by turning the ENG into electricity, capturing the CO2 again, or we can supply the ENG as a green molecule to off-takers that want to have a direct replacement for natural gas, and then they use it in their process and they capture and bring back the CO2. So that's where we start to close the loop. So we are bringing green electricity turned into molecules to our customers, and then we're going to capture the CO2 because we don't want that CO2 to be emitted to have a climate impact, and we bring it back to the origin where we then basically combine the CO2 with fresh hydrogen, thereby creating this green cycle. The only exception to closing the loop is that if we have sources of biogenic CO2 or climate neutral CO2 that we do not have to bring back, or maybe there's applications where it's difficult to capture the CO2, there we can allow to have that CO2 emitted again because it came from climate neutral sources. But the grand scheme is to close the loop and make this a complete recycle system where the CO2 is just a carrier to bring the green hydrogen or the green energy to our customers.
So maybe finally, what's giving you hope right now in the face of the vast climate challenge?
Yeah, the thing that really gives me hope is that molecule, the ENG, the electric natural gas, because being an engineer and working in the industry for over 20 years, I know there's different solutions for technical challenges, and we have all these discussions about ammonia, about methanol, about LOHC and liquefying hydrogen. And yes, there's going to be applications and need for all of those, but unfortunately, they all require a lot of changes to the infrastructure. You need to build new ships, you need to build new pipelines, and then the customers have to retrofit their assets, they have to change their equipment, and that all unfortunately takes time and money. And even if it economically works in some cases, it still takes a lot of time to build the infrastructure, and that's really the main problem because we don't have that time. So what gives me hope is that with ENG we overcome all these limitations. ENG is a molecule, synthetic methane, that we know how to transport, that we know how to distribute. Everything's in place, so we can act today. The only thing that restricts our speed at which we can decarbonize is the speed at which we set up the electrolyzers and produce that ENG. But the infrastructure to reach the customers, the application in their processes can happen today, and that's really giving me hope that we now have a solution that if we put the right regulatory framework in place, we can really jumpstart and kickstart this decarbonization route.
Thanks, Jens. We're going to have to leave it there for today. Thank you to all of you who've watched. If you want to learn more about TESS and just other technologies in the green sector, please keep an eye on TESS's website and social media channels. See you soon.